Have you ever really thought about how a computer learns to see? Well, back in 2014, a paper came out that didn't just teach an AI to recognize images. It taught it to see deeper than ever before. And the amazing part? It wasn't about some fancy, complicated new trick. It was all about one deceptively simple idea that completely changed the game for computer vision. All right, let's get into it. So here's how we're going to break down the story of this incredible network, VGG. First, we'll set the scene with the high-stakes race for computer vision. Then, we'll look at the one simple question the VGG team asked. After that, we'll check out their secret recipe, see the results that proved they were right, and finally, really dig into why this model from 2014 is still so important today. Okay, let's paint a picture. It's the early 2010s, and the ImageNet challenge? That was the ultimate proving ground. Think of it as the Olympics for computer vision. Research groups from all over the world were in this fierce competition to build the absolute best image classification model. The bragging rights were huge. Then in 2012, this model called ILSVRC just shatters all the records. It was a massive breakthrough, and it proved that these things called deep convolutional neural networks were the future. The floodgates just blew wide open. And suddenly, the biggest question on everyone's mind was, okay, what's next? How do we top that and build an even smarter computer brain? And you can see the trend so clearly right here. In 2011, the winners were kind of shallow, architecturally speaking. Then bam! 2012, ILSVRC proves that going deep is the way to go. So by 2014, the team from the Visual Geometry Group at Oxford, that's VGG, they took this idea and just ran with it. They decided to go very deep. Now, while all these other teams were trying to cook up these super complex, wild new network designs, the VGG team, led by Karen Simonyan and Andrew Zisserman, did something different. They took a step back. They decided to focus on just one thing, and only one thing: depth. And they literally say it right in the paper. Their mission is crystal clear. They weren't trying to reinvent the wheel here. They just wanted to figure out really systematically what happens when you just keep making these networks deeper. You know, it was such a clean, focused, and, as it turns out, an unbelievably powerful question to ask. And this was the core of their whole experiment. It's just brilliant, classic science. To really understand what depth does, you have to isolate it. So they locked down everything else, all the other knobs and dials, and then they just did one thing. They kept adding more layers. This gave them this beautiful series of models, from shallow to super deep, and it meant they could be sure that any performance change was only because of depth. Okay, so how'd they pull this off? I mean, you can't just keep stacking layers on top of each other without a really smart design, right? Well, the key, the secret ingredient that let VGG go so deep, was their decision to use only tiny 3x3 pixel filters. Let me show you why this was such a genius move. Okay, this is where the magic really happens. A stack of 3 of their little 3x3 filters can actually see the same patch of an image as one big 7x7 filter. But, and this is the kicker, the stack of small filters is way better. First, you get 3 nonlinear layers instead of just one. You can think of these as extra decision-making points, making the network's logic more sophisticated. And second, it's way more efficient. The big filter costs you 49 parameters, but the stack of 3 only costs 27. So you get a smarter network that's also cheaper to run. It's a total win-win. And here they are. This is the family of models they built to test their idea. You can see how methodical they were. They start with configuration A, that's 11 layers deep, and they just keep going, all the way to configuration E with a whopping 19 layers. It's the same basic blueprint for each one, they just keep adding more floors to the skyscraper. All right, so the stage is set. They've got their theory, they've got their elegant architecture, they've built all the models. Now for the moment of truth. Time to run the experiment and see if they were right. Does going deeper actually work? The answer was an absolutely resounding yes. Just look at this chart. This shows the error rate, basically how often the model gets it wrong. And you can see, clear as day, as the network gets deeper, the error rate just drops. Model A, the shallowest one, is up here at 10.4% error. By the time you get down to the 16 and 19 layer models, that error is cut down to just 8%. Deeper was definitely better.
So, the main takeaway is simple, but it is so important. Their experiment proved it. A deep network made of simple, small parts is way better than a shallow network made of bigger, more complex parts. Depth, when you do it the right way, was the real key to unlocking performance.
But they didn't stop there. For their final competition entry, they took their 2 best models and had them work together as a team. And they landed on this number, 6.8%. That was their final test error. An incredible result that landed them at the very top of the 2014 ImageNet Challenge and cemented VGG's name in the history books.
But look, winning the contest is one thing. The real story of VGG, the reason we're still talking about it all these years later, is what happened next. Its real impact goes way beyond just one competition.
You see, VGG became the poster child for something called transfer learning. The idea is actually pretty intuitive. You take the visual brain of VGG, which has already learned to see all these useful features, edges, textures, patterns, shapes, from looking at millions of photos, and you use that pre-trained knowledge as a head start for a totally different task. You don't have to start from scratch anymore.
And this is what blew the doors wide open for so many researchers. People quickly realized that VGG's brain was incredibly good at, well, almost everything. You wanted to detect objects in a picture? You'd start with VGG. You wanted to automatically write a caption for a photo? Start with VGG. For years, it was the absolute go-to foundation, the bedrock for a huge amount of new research. So in the end, the story of VGG is really a beautiful lesson in the power of simplicity. It proved that sometimes the biggest breakthroughs don't come from more complexity, but from pushing one single, fundamental idea to its absolute limit. It perfectly answered the question of its day, but it also left an even bigger one hanging in the air for everyone that followed. If just going deeper was this powerful, what came next?